first of 3 talks on monitoring this afternoon. Bjorn is here from SoundCloud, and he just mentioned he didn't put Prometheus in the talk title, so he's afraid that nobody would show up, but there's quite some people here. He's going to give you an intro into Prometheus, and I think try to convince you why you should be using labeled time series for all your monitoring and alerting. Right, so please welcome Bjorn.
Thank you. Sander stole my introduction. Okay, so I actually just realized I didn't put Prometheus in my title, but I put the logo there. I also have stickers, so after the talk, if you catch me in the hallway, you can get stickers. They're usually pretty popular, so perhaps that's why I don't have to put Prometheus in the title, because everybody knows me. I'm like one of the, most senior or longest standing or busiest contributors. I mean, there are people who are longer with the project, who actually founded it, and also people who contribute more, but I'm somewhere in the middle, I guess. Okay, no, it doesn't work. No. Ha, now it works. Okay, so I was asked to give an introduction to Prometheus. Now I have this weird ambition to never give the same talk again. So, I mean, it would be the most efficient thing if I just toured around the world and gave the standard Prometheus introduction talk. But in a way, it's like a music performance or something. I want to do something different. So in this talk, I'll focus on some high-level concepts of Prometheus. This is the architecture diagram, so this would be the usual start. We go through the architecture diagram, I explain all the basic things. It's a pool-based monitoring system, like self-sustained single host, time series database, alert manager, dashboarding, whatever. But I want to focus on some high-level details. Advantage is, nowadays, people sometimes already know Prometheus, so if I just tell the same thing all over again, it's boring. Of course, some others of you will know nothing about Prometheus, but like talking about some concepts is good for everybody. If you know Prometheus, you will get some new insights. If you don't know it, you will still understand the concepts. And if you want to get all the basics in 50 minutes, there are many talks on the internet. This is my personal favorite. It's not even my own talk. It's Brian Brazel, who is another super important person in the project. I made you a short link for YouTube. So this is literally in 50 minutes everything that's important about Prometheus fundamentals. It's really great. It was FOSDEM last year. Yeah, great stuff. And from there, you can take it from there and do your research. I want to focus on concepts, and I even want to focus on concepts that I usually don't focus on. So these are the concepts I usually like. Like I tell people how Prometheus is white box monitoring and why you really want white box monitoring in a modern world, and not just the black box monitoring here. Although you need to instrument your code for white box monitoring or do something while like black box monitoring tries to kind of be invisible, just simulate normal requests. Another thing is host-based versus service-based monitoring, which I label in quotes traditional versus modern monitoring. That has to do with we are not running individual Apache web servers anymore for our side. We have like distributed, redundant systems, all the jazz. And I also like to put Nagios in this quadrant and Prometheus on the other one to kind of emphasize how much Prometheus is an antithesis of Nagios. Of course, this is not the whole truth. It's all overlapping and a bit blurry. And also, I don't want to talk about these concepts. I put my concepts into the title. I want to talk about 2 concepts. The one is time series, and the other one is labels. And then I want to apply it to something that is not a concept, but more a thing, alerting. Yeah, and after all of that, you will be sold for Prometheus, I hope, right? So this is a quote from the Bible, in a way, like my personal holy scriptures in my day-to-day work. I'm, of course, biased. I have a history at Google as a site reliability engineer, and people I know, including my own boss, back then wrote a book called Site Reliability Engineering, How Google Runs Production Systems at O'Reilly. Blue book, really nice. It's also available by now, free to read in your browser as an HTML version. So this is really great. If you probably know about it anyway, but if you don't, and you're anyway interested in running large-scale production system, you should read that. Must read, right? So there's a chapter 10, which is kind of my favorite chapter because it also covers Prometheus. It's by Jamie Wilkinson. We will talk about him a couple of times in this talk. So even though Borgmon, which is a traditional, in a way, monitoring system at Google, which is very similar to Prometheus. Google just did this 10 years ago already, right? In the open source space, this is all fairly new, but like the big players use something like that for quite some time. So even though Borgmon remains internal to Google, the idea of treating time series data as data source for generating alerts is now accessible to everyone through those open source tools like Prometheus, Riemann, Hacker, and Bosoon. That's also interesting that at the time when Prometheus got like a public launch, there were also a couple of other tools showing up more or less at the same time. There is perhaps a bit of like remote spiritual common ancestry, but it's more like in science, where like people in different parts of the world independently come up with the same solutions for the same problem. Also, like Prometheus is pretty old, like in a way, 2012, was started 2012, but it was like we didn't make noise about it. It was an open source project, but it was like you had to know what to look for. And in 2015, we went public, and now everybody knows us, hopefully. Okay, let's go back to Nagios. Alerting is the thing, right? If you say alerting, most of you probably think about Nagios. This is the proverbial system for alerts, right? If I say time series, you probably don't think about Nagios. You think about something like Graphite. Graphite is the proverbial, whatever, monitoring time series system. And then probably this is like two different universes. I mean, you have it in your day-to-day work. It's both monitoring in some way, like Nagios sends you a page, and then you look at your dashboards to find out what's actually wrong, right? So there's a loose connection. Also, sometimes the other way around. Your dashboard looks weird, and then you think, why is Nagios not sending me a page, right? Because something is weird. Or perhaps it does for other reasons. Also, to be fair, you can have plugins in Nagios that actually query Graphite for certain circumstances and then send you an alert. So there is a loose connection between them, but in a way, it's two different universes that kind of have some links. Now, in Prometheus, we see like graphing, time series, dashboarding, whatever that is. This is for us, it's the same thing as alerting. It's just two different sides of the same coin. We have like many mantras or proverbs in the Prometheus universe, and one of his is, if you can graph it, you can alert on it. So we have an expression language where you can query the Prometheus time series database and graph it. Beautiful graphs nowadays are done with Grafana. Grafana can also access Graphite, ironically, but it can also access other databases like Elasticsearch, which was somebody talked about that today, right? So it can also access Prometheus, so it's all at the same place. You can make dashboards and mix and match, but you will paste in Prometheus expressions. It's called PromQL, or expression language, into Grafana to make beautiful graphs. And if you write alerts in Prometheus, you will find yourself again writing PromQL expressions. It's really the same thing. So once you have a nice graph and you think, okay, if this graph goes above that line or the slope is like higher than that, you already have an alert. Very easy. Okay, to demonstrate why that is so good to have time series information in your alerting system, I use the classical example of a disk full alert. Now, disk full sounds horribly old style. You care about the single disk. You still have to do this even in the modern world. But there are also other things like resources that are totally fine if you use 99.9% of them, but you're not fine if you use 100.01% of them. Let's say RAM and your or whatever. So this is generally applicable. I just use the good old disk full alert because that's so easy to imagine what's happening. So if you have a Nagios alert for disk full, you probably set it to some threshold like 85%. And if your disk is 85% full, you alert, right? There's no notion of history. I mean, Nagios has this notion of repeated test failures. So if a check fails 3 times, you might get alerted, or 4 times or 5 times, whatever you configure. So this is a bit of a time dimension, but in general, it's not really a time series database. So what you do, you set 85% disk full, and as soon as your disk is 85% full, you get paged. So now this is a scenario where the disk is actually full all the time, which is fine, right? You have filled your disk, you're reading from it now and then, perhaps the operating system is doing tiny things, so it's wobbling a bit around, but it's kind of fine to have a 90% full and be good with it, right? But Nagios will send you pages all the time. That's not fine, right? On the other hand, this is another scenario where your disk is very empty and then some rogue job starts to fill the disk very quickly, and you hit the 85% threshold, you get a page, and 5 minutes later the disk is full and you are screwed, right? Nagios thinks the left one is a reason to alert and this is fine, right? It's not. But how to find out about that? You need historical information. You need to do something like, let's find out what the slope is, right? So this is what you can do with time series data. So you can see, okay, it's 90% full. That might be a reason to be worried, but like it's going down a bit. Okay, now it's going up, but at the current rate, it will only be full in 6 hours. And before that happens, it's going down again. This is actually fine. On the contrary, if you have this thing, so suddenly you have a huge slope and you know in 3 hours my disk will be full, you can alert the operator 3 hours before the disk is actually full, and you can do something. Stop that job, move to a different host, whatever. So, a quite obvious way why time series data is good for alerting. There are less obvious ways where you want time series data, and that's about counters versus rates. Perhaps you already know what I'm talking about. If not, even better, I'll explain it to you. Here's Jamie Wilkinson again. I just stole these graphs from him because he made them once for a talk, and now I'm recycling them all over again. So this is a time series, right? So you have time and you have values over time. A time series always has a limited resolution. Like Prometheus, for example, collects the data every 15 seconds, every 30 seconds, whatever you configure, collects them from the targets you monitor. So let's assume your target is just a binary that serves some microservice, and it tells you how many queries per second it's currently serving. And then you put it into your time series database, and you get this nice graph. I mean, almost a graph, dots, right? So first of all, one problem is, what is actually queries per second at a certain time? This can never be like a zero-time thing. You can never say, I'm serving 5 QPS at this moment. It's always some averaging. It could mean you have served 5 queries in the last second. It could also mean you have served like 1 query in the last 200 milliseconds. It could mean you have served 50 queries in the last 10 seconds. That's not obvious, needs to be documented, and it's also difficult to change if your instance reports queries per second. But that's only one problem. The other problem is your actual traffic might look like that. So all those high frequency changes, which could be like peaks and drops in traffic, you have no clue if they have ever happened, if they are like high frequency changes. If you want the science part, Nyquist-Shannon theorem tells you exactly what's happening here. If you sample at a certain rate, you cannot get high frequency changes. It's just lost information, essentially. Okay, these are the two problems. Now let's look at the right one. This is a different approach, and that's what you usually do in Prometheus, not only in Prometheus, but we're using that approach as well. You are not asking the instance how many queries per second it is currently serving. You are asking the instance, how many queries have you served during your lifetime? That's called a counter, and it only ever goes up. So this is, again, limited resolution, but you know there can't be any ups and downs in it because the counter only ever goes up. Okay, right? Queries served during lifetime. This is not what you want. You want queries per second, right? So let's look at it, how it looks in a real Prometheus server. So Prometheus, the server itself, has a web interface where you can just try out PromQL expressions before you paste them into Grafana. It's like for ad hoc exploration. Also nice during outages to explore what's actually going on. So this is a metric. This is a counter API requests served during my lifetime. And we call it total by convention in Prometheus. It's just a naming convention. People make that wrong, but yeah. And then you plot it and you see the counter is going up. Like you see like hundreds of thousands of queries served, and this is also like many hours here. So what is this good for? I mean, if you have a really nerdy brain, you can already see what the slope is and estimate, like the steeper the slope, the more queries you are serving. Now imagine you are losing data points, your resolution is limited, you will still get the total number of queries. You just don't know when they were exactly served, but you will never lose data, you will only lose resolution. But looking at that graph is not nice. You want the first derivative, essentially. And Prometheus has this expression language, PromQL, where you can act on time series data. And guess what? This is real data, right? So if you do the rate, which is essentially give me the slope and normalize it to per second, then you get this beautiful graph. This information is in this graph. It's just difficult for humans to spot. Here you can also specify this time interval you use to calculate the QPS. So this is great because you have all the information in your time series database, and at any time you can say, please average over 1 minute, 2 minutes, 10 minutes a day, whatever. It's not baked into your binary that serves all those traffic. Yeah, and then you see, like, you get ups and downs. Resolution is limited, as it has to be, but you will never miss a peak. So, great stuff. Okay, now let's talk about something else where we get into the label business, aggregation. So in reality, modern world, you don't have a single instance serving your microservice. You have tens, hundreds, thousands of instances. And every single instance gives you a time series database, gives you a time series that shows up in your database. You have to aggregate it in some way. And since there are so many time series databases get overwhelmed. You might have used StatsD as a data source for Graphite. It's a relatively modern approach and like pretty good. Helped us a lot at SoundCloud before we had Prometheus. But there, you usually bake in some aggregation into your monitoring setup already. Like you have 100 instances serving that service, they all feed into the same metric. And then you have it aggregated, you can never change that. So Prometheus tries to give you both. And this is another quote from the Bible, again from chapter 10, which is written by Jamie Wilkinson, personal hero or something. We need monitoring systems that allow us to alert for high-level service objectives, but retain the granularity to inspect individual components as needed. So this is one of the very cores of Prometheus. The whole alerting thing, like the classical Nagios alerting, where you send a probe to a server or a service instance, and once it's down, you get paged. I mean, you can do some more sophisticated things with Nagios as well, like it grows into that. But originally, it was the idea. If a check fails, somebody gets paged. So in distributed systems, you know they are so large that always something will fail, and they're also designed to tolerate that. And you don't want to alert somebody for something that the system can tolerate. So what you want to go for, and it's called symptom-based alerting, you want to go for high-level service objectives. Ideally, you have a service level objective or even a service level agreement with your customers where you know if I serve a 99th percentile latency more than 100 milliseconds, I'm out of SLO, and this is exactly what you want to alert on, nothing else. If you are serving everything within SLO, fine, no reason to wake somebody up. If a breach of SLO is imminent or already happened, you want to wake somebody up. And that's the high-level service objective thing. But if you have been woken up and now you want to find out what's actually going wrong, and you're just seeing this graph of like latency and you don't know where's the problem, then you want to drill down. You want to drill down into individual instances. What's going wrong here? Is it the new software release I've pushed? Is it a single slow disk? Whatever, right? And this is where the inspect individual components gets into the game. So now let's look at concrete, real data from Prometheus. Again, our query. And the previous slide was real data, but it was a lie because I only showed you one time series. In reality, we have hundreds of instances serving the same query. So you see something like that. And this is really intriguing. You see there's a population of instances that have served more queries in their lifetime than another population. Perhaps this is like an older binary that runs for longer, or we had these running for a while and then we needed more capacity and scaled up more instances. Who knows? This is like a weird one, some other weird ones, and you see this line. What is that? That's a counter reset. So this is where an instance, I mean, in the old times of 32-bit counters, you had counter resets when you just had an overflow. But usually counters nowadays are big enough to not overflow. But like the instance could restart for whatever. It seg faulted, I don't know what. And then it gets restarted, as you do in a cluster management system, and then it starts from 0 again. Also something you have to take into account. Now, let's do the rate thing. So the rate thing, again, it looks at every data point, looks 2 minutes back, calculates the queries per second served, and then you get this beautiful curves. So there is funny stuff happening. This is actually the drop. You can see it here, but it's taking this into account. Like Prometheus has counter reset, there's math in Prometheus to compensate. And then you get 2 populations again. But this is interesting, right? So these, you could kind of guess that this is fewer curves than this. So like a smaller population is serving more queries per instance than a larger population. Quite interesting. And then you have this curve here, which is not serving a lot of queries. Weird, right? I mean, you can look at it. I deleted the labels from the graph here. But like in Grafana, you can hover over the graphs and see all the labels. So you would actually see that this is a canary instance, and these are like 2 different setups of our service. But this is not something you want to see in a dashboard. It's super confusing. You want to aggregate it in meaningful ways. So let's move this up. One aggregation possibility would be, let's just sum everything up. Then you get one curve, and you get the queries served fleet-wide. It's like STATC approach. Yeah, sure, but sometimes you want to aggregate along dimensions, and that's where labeling gets into the game. So everything in Prometheus is labeled. It gets an instance label where this one time series is coming from. It gets a job label, which would be like the API we are serving here. But you can add any number of labels you want to. Let's say something like an environment. Is this production, canary, test, a cluster? Perhaps you have multiple clusters in different geolocations. And you add all those labels, and then you can sum up, but along those dimensions. So you don't get one sum. You get a sum for every combination of that. Every job, every environment, every cluster gives you a different curve. And in this case, you get this here. This looks much nicer. Now, question is, how many curves do you see? 1, 2, or 3? And the answer is, there's one curve here. This is our canary curve, which doesn't serve a lot of queries. And then there is, these are actually 2 curves. It's difficult to see at that resolution. So there are 2 curves where in aggregate, in sum, both populations serve the same number of query. And if you look at it, it's like a different cluster. And that's I told you it's real data. I got this like 2 days ago somewhere at SoundCloud. So we have an experiment running where we have some instances running with a higher CPU allocation and memory allocation, but twice the number of queries, and other instances run with less CPU and less memory and half the number of queries. And you can nicely see how both populations get the same total number of queries, but then you see there are like more instances in here than here. And of course, you could do other aggregations like count, average, and you can explore all those things. So great source of data where you can dig into. And once you have a nice query and you can graph it, you can also write alerts. Okay. Now something different about labels. Labels are used elsewhere. Labels are used in Kubernetes, for example. You might have heard about Kubernetes, hipster container orchestration solution. And everything is labeled in Kubernetes. It runs things in pods. Pods can be multiple containers. And every pod is labeled. Like I showed you pods here that belong to the API app, right? They all belong to API. But then there are different environments, production, canary, test. Different binary versions, it's all in the labels. And why do they use labels? They use labels so you can select things. So you select something like all the API pods in environment, production, and canary to serve the public API service. So you define a service by selecting pods that are in charge of this service. And you use a label selector. Now, why labels and not like hierarchical structures, hierarchical trees? The reason is that you also want to select sometimes along other dimensions. Let's say you have a resource crunch. You want to select all pods that just run tests, but not only in the API app, but in all apps. And then you have a selector, which is just env equals test. You select all pods, and then you issue a delete command to get more resources. Like you're selecting along those label dimensions and not along a tree. And a similar thing can happen with metrics. Like this is, again, a real metric as it could exist in graphite. If you have used graphite, you know you have those dotted metrics. Ampelmann is our routing system. In Amsterdam, we have a data center. This is the IP number of that specific router, and it routes, among others, API mobile requests, and this metric counts the 5xx for API mobile. In Prometheus, that looks almost like the same. It's a counter with total. You already see the labels are kind of easier to read because they have a name, like you don't have to guess. But that's just syntactic sugar, I guess. But yeah, you can see it's the same thing. So now in Graphite, you can run queries for your graphing or alerts or whatever. Like this is the sum, aggregation, of all queries that this router serves, no matter which backend, no matter which HTTP code. This is fine, right? That works. And Prometheus can do the same. Now this is getting interesting. If you know Graphite, you are feeling pain now because you know this is super expensive. If that wildcard is at the beginning of your metric name, you have a problem because this is like a full table scan in a database. This has to traverse the whole tree of metrics because the wildcard is here and has to look everywhere. But these simple queries here, I want to know API mobile 500s everywhere, not only on that router and in Amsterdam. Easy query, difficult for Graphite. In Prometheus, there's no hierarchy, right? It's exactly the same query cost, those two things. You can aggregate whatever you want. And this is my punchline at this point. Labels are the new hierarchies, right? Don't think hierarchical, think in labels. All labels are made equal. OK, now this is another use of labels. So this is already the result of a recording rule, different thing in Prometheus, like something more complicated, 99th percentile with labels. This is something you probably want to alert on your 99th percentile latency. And all those labels are coming from Kubernetes. So this is another thing. If one system uses labels, like Kubernetes, and Prometheus uses labels, you want to connect the dots, right? So this is what you can do with monitoring. You can just get all the labels from Kubernetes into Prometheus, and they will all show up. You can graph them. So they are, whoop. Where's my, now it's off. Anyway, you see, there it is. You can see like production is serving at this latency and the canary is actually doing better. So next software release was an improvement. And it ends up in your alerts. This is how alerts really look in Slack. So all the labels are here and you see in your alert already what's going on. Great stuff. You put a label in your Kubernetes pod and see it in your alerts. Another thing where you can use labels for is alert grouping. I don't read this out now because we're almost out of time, but this is a very common thing. If you ever have used Nagios in large-scale installations, a whole rack goes down with 80 servers, you will get 80 alerts that every single server is down, right? You want to group that. It's one incident, essentially, and this is what you really need. You don't want PagerStorm for things that are essentially an individual thing. And in Prometheus, you have those labels and you can group by it. Like this is for an example from alerts about Prometheus, meta monitoring, right? So if a single Prometheus server has a problem, then you don't want to get a million alerts about it. You group all the alerts of that Prometheus server. This is actually even
from
grouping
the
alerts
peers
of a
of
pair of
peers.
Prometheus server, which is a pair for redundancy. And you see something is wrong with the sample order, so both have the same problem, but you get one alert. You can look at the individual alerts, but you get one page with a list of things that are currently going on.
Cross.
OK, so this is my pitch for labels and time series.
Orange.
Do we have time for questions? We were like running a bit late anyway.
Yeah, we will have time.
OK, you can ask me about anything, like everything in general about Prometheus, and I'm also available here in the hallway track later.